This is a right triangle, so that's 90 degrees. And we know the other angles add up to 90. Angle X plus Y, they have to equal 90. I'm sorry, Z. I meant Z there. This is called an isosceles right trapezoid. And what that means, I'm sorry, right triangle. And that means that both of these angles are the same. So really X equals Z. So for you know that this is really X plus X equals 90, or 2X equals 90, or X equals 45 degrees. That's the answer they're looking for there.
All right.
All right. Question 2. Sorry, I get that snipped in here. I try to figure out what I'm going to say before I snip it in here, and sometimes I'm surprised at what they're asking for. So this number here and this number here, those are the lengths of the sides, and BC is the hypotenuse. It's sort of an odd orientation. It's more standard to kind of see it like this, where the two sides are 1, and we're trying to figure out BC here. So do you recall the Pythagorean theorem from class or from a video or something?
Yeah, a little bit.
Okay, so A and B are the legs. Okay, so they're the shorter ones. So in this case, A is 1 and B is 1. So we have 1 squared plus 1 squared equals C squared. So I'm just putting the numbers into that formula there. So that gives you 1 plus 1 equals C squared, 2 equals C squared, C equals the square root of 2. So this C is referring to the right triangle, A, B, and C. C is the hypotenuse, which is what it's asking for here in this problem. Is that clear?
Can you go over that again?
Yeah, I didn't think so. You know what? That's the only one of those. Yeah, unless you get more, I kind of think we should just leave it. If you really want me to, I can explain it again, but that's the only one like that.
All right.
It seems out of scope. That's why I'm saying it that way. Is this 18? Is this
I think
1?
so.
Is it a
I
1
don't know.
followed by something?
I think it's 18. That's what it looks like
Okay.
on my screen.
It does matter. I think it is 18. Okay, but ignoring that for a moment, all the angles are the same. So if all the angles are the same, that means that all the sides are the same. Because if all the angles are the same, they're all 60, and that means it's an equilateral triangle. So that means that every side is the same. That means that n squared equals 3n plus 18. And you might be thinking, well, okay, so what? Well, you actually know how to solve this. You know how to solve this because of previous classes that you've taken. If you move everything to one side of the equation, do you remember how to factor this? Do you remember that from a previous class?
Oh, I know we did it. I don't remember any of it.
Okay, so because there's a 1 in front here, this minus 18, you're looking for two numbers that multiply to minus 18, but add up to negative 3. So I'm just going to write them all out over here. This is just a good exercise for us to do. Negative 2 and 9, 2 and negative 9, 3 and negative 6, negative 3 and 6. Do any of these add up to negative 3?
Yeah.
And the ones I'm circling do. So if you're at n plus 3, n minus 6, if you were to FOIL this, which we're not going to. If you were to FOIL this, you would get back to what you previously had. So now you set each of these equal to 0. So you end up getting n equals -3, n equals 6. This is not the answer, but this is what they're asking you to do here. So we can actually find the value of PQ. If I snip in the question again, which I think is probably worth doing, PQ is this length over here, which is the same as the other ones here. Okay, so since you know n, let's just say n is -3. If n is -3, PQ is n squared. Well, what is -3 squared? Well, that's 9. Let's say n is 6. Well, PQ is still n squared. You get 36. So there's actually two possibilities here, which is really strange, but I mean, I don't make these questions, so I have no judgment on these because I have no idea what they're thinking, but it looks like PQ could be 9 or 36.
All right, should I put both of them?
Yes. It also looks like your instructors or this thing is emphasizing more of the algebra skills that you previously learned. Don't know why, but that's what it looks like. Okay, measure of angle K. So that one's over here. We're trying to find this one over here on the left. This 28 degrees is also this 28 degrees by vertical angles. Vertical angles means that they're congruent. This triangle on the left here is an isosceles triangle. We know that because two sides are the same. If two sides are the same, then two angles are the same. I'm going to call it X and X. So we know that X plus X, because they're the same, plus 28, because we know that by vertical angles, has to equal 180. So now you just have to solve for X. So give that a try on your own there. Move the 28 over, combine the two X's, and see what you come up with.
76.
76. X is 76. Yep, that's right. So that is the measure of angle K. That's this right here.
Okay.
So that's your answer to that one. All right, so this one, all the sides are the same. So if all the sides are the same, it's a equilateral triangle. In an equilateral triangle, all the sides are congruent, sides same, and the angles are the same. What is the angle measure of each angle in an equilateral triangle? Do you remember that?
60.
60. So this right here, this 3t, 30t plus 20 has to equal 60. So for some reason they chose numbers that didn't work out well. You end up getting t equals 4/3, or I don't know what your thing accepts, but 1.3 repeating when you solve for t on that. Is there anything there you'd like me to go over again?
No, I got it.
Okay. For this one, can you tell me, is that an n or a pi, or what is it? Kind of looks like an n.
It's n.
N. Okay.
I think.
Yeah, I think it is too. So this is an isosceles trapezoid. So an isosceles trapezoid with two sides the same, then the angles are the same. What is this angle over here then? T, if this is 3.5n.
3.5n.
3.5n. And what do we know that these all have to add up to?
180.
180. So it doesn't look great to begin with, but 3.5n plus 3.5n is 7n, plus 11n is 18n. You end up getting n equals 10, which isn't too bad at all.
All right.
Okay, so n is 10. Yay, got that down. We're up to 8. To 8.
Now 7, right?
7.
Yeah.
7, because I'm not paying attention. Okay, don't do that. Oh, is that on your side? It is on your side. Oh, maybe not. So this one has a weird artifact from. So it's. I know it's not. There's a line here and here and here. So these are all the same. So that means each of these angle measures is 60. Is that okay?
Yeah.
So we're trying to find the measure of angle A. That means this is 120 over here because these two angles add up to 180 because it's a straight line. So this triangle over here, I'm gonna redraw it just because I think it'll be clearer here. If this is 120 and these two are the same, we can call this x and this x. What do they have to add up to? All three of these.
180.
180. So like it's fairly routine here. Like they either add up to 180, add up to add up to something else, but they almost always add up to something or really equal each other. So here you end up finding that x is 30, and that is the angle measure of A, because A is like there or there depending on.
All right.
All right, now we can go to 8. All right, so we're trying to find x. X is that angle there. We need to know the angle, this angle that I'm pointing at with my first arrow, and then this angle that I'm pointing out with the second arrow. So the one on the left and the right, we find the same way. We know that these are both isosceles trapezoids. So I've done that a couple of times here. Can you just figure out the angles down here? They are the same. All three of them add up to 180.
Yeah. Oh, 52.
52, very good. Now do the same thing over here. These two angles are the same. This one's 102. What is the angle measure here?
$39.
Agree, 39. They're both 39. So what I've done here is just redrawn the picture with only the stuff that you care about. This is a straight line. As poorly as I've drawn it, it's a straight line. These three have to add up to what when it's a straight line?
180.
180. So go ahead and solve that for x, please. Do you have a number for me?
Is it 91?
Yes, yes. Okay, I guess we can go on to 9 here. 9 has no picture. It's the this is part of geometry that a lot of students struggle with. If you can't make the picture, usually you can't solve the problem. So I'll try to set up the picture because that's really the key here. It says an obelisk, maybe pronounce it right. It's a tall, thin, four-sided monument that tapers to a pyramidal top. Okay. Most well known as the National Mall. Pyramidal top is an isosceles triangle. Each face. So what they're saying is, let me draw. This is a face, and then there's another face, and then there's another one back behind it, and there's 4 of them usually. So this is like the top of the monument in DC. Goes way down and ground level, something like that. I think all that's unnecessary. It says the height of each triangle is 55.5 feet. So I think they're saying that's 55.5 feet, and the base of each triangle measures 34.4 feet. So that's going all the way across. Find the length to the nearest tenth of a foot of one of the 2 equal legs of the triangle. Height of each triangle is, the base of each triangle measures. Okay, I actually think that this is incorrect. So I think the height they're referring to is if you imagined a pyramid. There's a place that goes into sort of like the center here. They're saying that's the height. So imagine that that's the height there, and then they're saying that the equal legs are. I don't know. I'm really guessing on this one what they actually want you to find, but I'm going to guess that this is 17.2 here, half of this, and they want you to find this length here. I could be totally wrong. And the base of each triangle measures 34.4 feet. Yeah, I don't know. Have you searched this one on the internet?
No.
Do you want me to?
Yeah, I'll do it too.
Okay. Well, I did find it in Chegg, which isn't surprising. Let's see if anyone answered it. Nobody answered it.
I have an answer here, I think. Wait.
Yeah, I'm not finding. Yeah, I mean, they're going 17.2. Yeah, they're doing this, what I showed you in the lower left. I mean, that's what one person sees. So they get L is approximately 58.1 feet. I'd probably go with that. Okay, so that ends these questions. I assume you're going to send a new batch or some other things for us to work on today.
Yeah, I have another thing.
All right, I'll stand by for those.
All right, and then it's only a couple because I know the rest.
Good.
I sent it.
Okay. I'll check for that now. All right, great. I got it. And see what we got here. All right. So number 3, find the circumcenter of the triangle, the given points. So I'm going to do my best to graph this correctly. So if this is the origin, we've got a point there and then a point to the right. 5, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. Circumcenter. I actually don't remember what that is, so I'm gonna search for that. It's some variation on many things, which perpendicular. Okay, so you have to find the perpendicular bisector of each of these. So the circumcenter refers to the perpendicular bisector. So for example, here they didn't give us great numbers, but for this one on the x-axis here, its perpendicular bisector is this line right here at x equals 2.5. And then there's one over here at y equals 2.5, and you're just finding the intersection of those two. There's a third one at the hypotenuse. So the hypotenuse has another perpendicular bisector. It goes like that. So the perpendicular part is that this and this are perpendicular. All you care about, though, I guess, is the ordered pair. It's 2.5, comma 2.5. We'll see how this one goes. 4, it looks like it's more sophisticated. So I'm going to try graphing this one again. We got 0, 7. Okay, so here's my origin. And then 0, 7, 1, 2, 3, 4, 5, 6, 7. Minus 3, 1 is here. 3, 1 is here. So it's an isosceles trapezoid like this. Okay. And we're looking for the perpendicular bisector of each of these. So this one on the bottom is the easiest. So the bisector is right through the origin. And see how this makes a right angle there? That's what it means by perpendicular. And then the bisector is that each of these are congruent. Now, in the previous one, it wasn't too bad. It was just a nice triangle. We need to actually find the midpoint between E and D and then F and D. Do you remember how to find the midpoint formula?
It's like square root. Wait,
That's distance formula.
oh no.
Midpoint's just the average of the values. So like from D to E, the midpoint would be 0 plus -3/2, comma, where am I at here? 7 plus 1/2. So it ends up being -3/2, comma 4. So if we go -3/2, comma 4, well, I didn't, so it looks like it's right there. Right there. And the other one's actually pretty close as well, or it's gonna be right there. And then you're trying to draw kind of this perpendicular to it. It's not that easy to do. If you have a really nice graph, you can see, if you're really good at graphing, you can see where it is there. So it looks like right there is where they intersect at. That's the circumcenter, the intersection of the perpendicular bisectors. I'm taking a few liberties because I know these are probably nice values. It looks like it's 0, 0,3 is your origins right there. I'm sorry if that's not clear. These are tougher to do. Can I move on to number 6?
Yeah.
Okay. All right. It says G to J, that's this one, and IJ are angle bisectors. Triangle GHI. Okay. So here's what that means. That means that this angle right here is also 23 degrees. Because if it bisects the angle, they have to be the same. If this one is 82.1 here, that's IJ, then it's really hard to show, but it's this one kind of right there is also 82.1. So that's what that first part of the information means. It wants you to find the measure of angle J to G to K. Huh. Well, that's just 23, I guess, degrees. I guess it just wants J to G to K. Yeah. Okay. That doesn't seem right. GJ and IJ are angle bisectors. Okay. I don't understand what the 64.3 is pointing to because it actually contradicts the answer here. Maybe it's pointing to right there. Like it really means to point in there. Anyway, I think it's just 23.
All right.
I think that's all it's asking for. I was just helping a geometry student with their exam, and I had to interpret what the instructor wanted, and that's what I feel like I'm doing with you. In some of these questions, I'm just always sort of uncertain about what it is that they want. So we'll try here. Okay. Raleigh designs the interiors of cars. He's given 2 tasks to complete on a new production model. Task 1. Triangular surface as shown in the figures molded into the driver's side door as an armrest. Okay. Raleigh thinks he can fit a cup holder into the triangle. He'll have to put the largest possible circle into the triangle. Explain how Raleigh can do this. Okay. So the largest triangle, I don't exactly know what it is, but it's going to hit it's going to do something like that. It's probably got it. Something like that. Because you could see, like, if you try to do one over here, it's much smaller. So it's maybe the words you want to say here is that it's tangent. It's tangent at 3 sides of the triangle.
What does tangent mean?
So this is tangent. I'm going to draw the triangle or circle, and that's a tangent right there. It touches only one place. So here's another circle. This is tangent to it. Your instructor might not like that word, or whoever's grading this. Yeah, I don't know what they want here. There is, okay. I know, maybe I can't remember this. So there's an inscribed circle. That's what they want here, is an inscribed. Inscribed means it's bounded. This one's bounded by the triangle. I think if you include some of those words there, you'll get points for this, or all of them.
All right, because I know we're doing this in class, but I didn't understand it. Like, I know it wasn't anything with like the tangent thing. It was
Inscribed would be better. Don't use tangent. Tangent's correct, but you probably haven't seen that yet in this thing here. So, okay. So the next one is, okay. So the next one is a circumscribed. Let me snip it in here. These are really confusing. Even for me, and I mean, I'm supposed to know what they're trying to ask you to do. So this triangle is supposed to fit in the center of a circle. So there's a circle that touches this, all three vertices, and that's called a circumscribed circle. So I think that's what it's looking for there. I think that's it for this grouping of questions.
yeah, that's all I have.
Anything else to work on tonight?
No, that's it.
Okay. Are we comfortable stopping here for the lesson?
Yeah.
Okay. Thanks, Maddox. Talk to you next time. Bye.
Thank you.
You're welcome. Bye now.